Okay, now let's look at the compositional alternative. We have one concrete document class. We have the title and content as before, but now we have strategy objects for storage, rendering, plus a list of behaviors. Now, instead of a is a relationship, like encrypted document is a document, we have has a relationship. Document has a strategy, a storage strategy, it has a renderer, and it has behaviors. Now, here are some of the configuration methods. These methods let us configure the strategies and add behavior at runtime. So, this shifts from fixed compile time relationships to flexible runtime composition. Now, let's look at the save method. Now, what we are doing here is we are giving each behavior a chance to transform the content before saving. This is where encryption happens. A behavior transforms content by encrypting it. Next, we use the storage strategy. We delegate to the storage strategy to persist the transformed content. And finally, we notify the behaviors after saving. We let behaviors react after the save completes. This is where versioning happens. A behavior records the saved version. This design pattern providing hooks that behaviors can plug into is the template method plus the strategy pattern. The document describes or defines the algorithmic skeleton, which is get content, transform, save, and react, but delegates the variable paths to strategies and behaviors. Now, let's look at the render method. We use the renderer strategy to format content, then let behaviors transform the results. The decryption happens here. A behavior transforms output by decrypting it. Now let's look at the strategy interfaces. First, storage. The contract for storage is to save and load given a file name and content. And here's a text storage implementation. We append a .txt extension and write as plain text. Rich text storage would use .rtf and different file system methods but follows the same interface. Now let's look at the render strategy. The contract for rendering is straightforward. It transforms content to display format. And here's an HTML renderer. We convert content to HTML. A plain text render would just return the content unchanged, for example. Now, for the behavior interfaces, this is where things get interesting. We are providing three hooks in the document lifecycle: before save, and after render. Now, here's how our encryption would use these hooks. The before save hook encrypts a content before it's saved. Next is the after render hook. This decrypts the content after rendering for display. And here's the after save hook, which is a pass through for encryption. It doesn't need to do anything here. Now let's also look at versioning, which will typically use these hooks differently. Versioning uses the after save hook to record each saved version. The other hooks are basically pass through. Right? This interface designing multiple hooks but allowing implementation to use only what they need is important. Each behavior can plug in into the lifecycle at the points that matter for its concern. Now let's see how we configure documents at runtime. Now here's a rich document with encryption and versioning. We create the document, set rich text storage, which will save as .rtf, set HTML renderer, which will display with formatting, add encryption, which will encrypt before save and decrypt after render, and add versioning, which will record each save. Four independent concerns configured independently. Now, if you want to remove versioning, just don't add that behavior. If you want to add compression behavior, if you want to add compression, you add a compression behavior. The document class never changes. Now, here's a completely different configuration: plain text with compression. Different configuration: plain text storage and rendering, compression behavior, no versioning, no encryption, same document class. Now let's look at the math. With three storage strategies, two render strategies, and four behavior types, that's 3 into 2 into 16 possible combinations, 96 configurations available through composition. I'm sorry. No class explosion, no duplicate logic, no multiple inheritance complexity. The key insight: inheritance bakes relationships into your type structure at design time. Now, if you need to answer a question like, is a colored bordered rectangle, is a rectangle. Now, these relationships are permanent. You can't decide at runtime that a rectangle should be colored but not bordered. Composition makes relationships explicit through configuration at runtime. A document has a storage strategy, it has a renderer, and it has behaviors. These relationships are visible in setup code and changeable at any time. You discover combinations as needed rather than predicting them upfront. Now, this is a fundamental trade off. Inheritance gives you a clean hierarchy but limited flexibility. Composition gives you maximum flexibility but requires explicit wiring. Choose inheritance for stable, truly taxonomic relationships, and choose compositions for behaviors that combine in various ways.